Hi everyone, this lesson is for geometry students. It is a review of area for our upcoming quiz. So let's get started. First question is find the perimeter and area of an octagon that has a side 5 and apothem of 3. So what that's telling me is that these side lengths here are all 5 all the way around, because if it is, actually it should have said regular polygon. If it is a regular polygon, then all the sides and all the angles are congruent. Additionally, what you would also need to know is what the value of the angle inside a regular polygon is. So what we would do is first we would use this formula to find the sum of the angles inside for the interior angles. And for that, we would go 180 times n being the number of sides minus 2. So n, which is 8, 8 minus 2 is 6. So I'm going to go 6 times 180 is 1080. So that's going to be 1080. And that's the sum of all the angles. If I want one angle, I am going to take that value and divide it by 8 because it has 8 sides. And what that gives me is 125 degrees is the measure of 135 is the measure of one interior angle. And so that being said, here's 135. We want to find the perimeter and the area. So to find the perimeter, all we would do is we would take the length of one side, which is 5, and we would multiply it by the number of sides, which is 8. So 5 times 8 is 40. So the perimeter is 40, whatever unit we're in, 40 units, not units squared because that's only area. So that's just perimeter is 40 units. In order to find the area, we're going to use the formula, this formula, that is to find the area of any regular polygon is 1/2 the apothem times the number of sides times the length of one side. And just for your own benefit, you know that the number of sides times the length of the one side is actually my perimeter, and which is what we just found. So now it's going to be 1/2 times my apothem, which I don't know, but I will find out, times 40. And so what we need to do is find the apothem, and they gave us the apothem. The apothem, which is this length that comes straight down like this, that would be 3. And so that's just 3. And actually I did a little bit extra work because I was thinking that I was going to have to find the apothem by connecting my radius down here and then, dividing 135 by 2 and then, using trig functions, etc. But I don't have to do that. So we just have to go 2 divides into 40 20 times. 20 times 3, 20 units times 3 units is going to be 60. And then that's units squared. So that's my area. Perfect. For these two problems here, we are trying to find the area. So to find the area of this shape, this is a trapezoid. The area formula for a trapezoid is the height divided by 2 times the sum of the bases. And so what we would do is we would take our height, which is 5, divide that by 2, so this is the area, times the sum of the bases, which is 3.2 plus 9.2. Remember that your height does need to be perpendicular, which it is. 3.2 plus 9.2 is 12.4. So this value is 12.4. I'm going to divide that by 2, and I'm going to get 6.2. So now I have 6.2, because this divided into the 12.4, times 5. And so 5 times 6.2 gives me 21. So the area of this shape, this trapezoid, is 21 units squared. For this value here, I want to find the area of this triangle, and the area of just a basic triangle is 1/2 the base times the height. But remember that my base has to be perpendicular to the height. And so in this case, you see how this being my base, if I were to extend it, of course the length doesn't extend, just it's making sure that it's perpendicular like that to the height. So we would go 1/2 the base, which is 4, times the height, which is 4.1, and they are perpendicular. So half of 4 is 2, and then 2 times 4.1 is 8.2. So the area of this triangle is 8.2, and that's units squared. So for these two problems here, we're going to work a little bit backwards because these are telling me, hey, here's the area, right? Here's the area. Find x, or find the height, or find the base. So for these two problems, I'm going to write out the formula, which says area of this parallelogram is equal to the base times the height. But in this case, remember, the base does need to be perpendicular to the height. So my base is 6, my height is x, and my area, though, is 12. So x is going to equal to 2 units. So my height is 2 units. For this problem here, I know that the area of a rectangle is equal to base times height, and the base and the height are already perpendicular because it is a rectangle. So my area, which is 75.4, so 75.4 inches squared, is equal to my base, don't know that, times my height, which is 9.2 inches. So I'm going to take 75.4 and divide that by 9.2. And I get 8.19 or 8.2. So x is approximately 8.2 units or inches, etc. Find the area of these regular polygons. Leave your answer in exact form, which means that I don't want any decimal equivalent. So for this problem here, this is a hexagon. It has 6 sides. If you use your formula to find the sum of the angles, remember this 180 times n minus 2, that is going to give me a sum of 720 degrees. But if I divide 720 by 6 sides, each of these angles, interior angles, is going to be 120 degrees because it's regular. The formula that I'm going to use for the area of a regular polygon is 1/2 ANS. My apothem times the number of sides times the length of one side. So I don't have the value of my apothem, but I do know that the number of sides is 6 because it's a hexagon. And I do know the length of each side is 8 because that was given right here. So what I'm going to do is I'm going to draw in my apothem. Drawing in my apothem is going to drop this down straight down. It's going to be perpendicular. It's also, by doing that, right, by doing that here, that cuts that length of the side into 2 equal parts. So then this part here is now 4. By connecting my apothem to my vertice, that makes it a radius. And at 120 degrees, which was that whole length there, now is actually 60. And then across from that would be the 30-degree angle, right? So across from the 30 degrees is 4. That would mean across from the 90 is 2 times that, which is 8, which is kind of cool because that gives me a little equilateral triangle inside here. But anyway, and then across from the 60 degrees is going to be 4. Root 3. So that value is my apothem. So I use the special right triangles for that. And because the directions ask me to leave my answer into exact form, I don't want to change that root 3. So when you're solving this, you're not using, by the way, the distributive property. You're not saying a half of this, a half of that, a half of that. You're not doing that. You're taking a half of one of these values. So I'm just going to take a half of, let's say, 8. And so that's going to be 4. So I have 4 times 4, which is 16. And then that value, 16, I'm going to multiply by 6, and I get 96. So I went 4 times 6 times 4, that's 96. So we've got 96 root 3. And this is unit squared because this is area. For this shape right here, we have an option. We have 2 options. I always like options, but these right here, I have 2 options. Number 1, because it is a regular polygon, that means it's an equilateral triangle. So all my sides and all my angles are congruent, which means all my angles are 60, and then all my sides are whatever the value. I don't have a value actually yet, but I can use the area equals 1/2 ANS, or I can use area is equal to 1/2 base times height because it's a triangle. I can still use the triangle formula. So what is important here is that they only gave you this piece of information because, number 1, they expect you to take this radius and divide this angle right here into 2 equal parts. So that's 60, which means these are both 30. And so across from the 30 degree is 4. Across from the 60, which would be this length here, is going to be 4 root 3. And then that's this length. And then across from the 90 it's not important. Actually, they didn't we don't need that value. They didn't ask for that value, so I don't need that. But it would be 2 times 4, which is 8. Just saying. Okay, so anyway, what we're doing now is we would say 4 root 3. So if I use this formula, the area is equal to 1/2 my apothem, which is 4, times my number of sides, which is 3, times the length of one side. So the length of one side is actually 4 root 3 plus 4 root 3, which makes 8 root 3. So half of 4 is 2, 2 times 3 is 6, 6 times 8 is 48. So the area is equal to 48 root 3 units squared. So that's the area. But I just wanted to give you the alternate option of finding the area using 1/2 base times the height. So the area equals 1/2. So 1/2 my base, again, is 8 root 3. But times my height is a little bit different because my height is not 4. This is a 2 to 1. So like going up, this is 4, this is 4, this is 4. So that's, my height is actually, this distance here is 12. And so times the height, which is 12. So half of 8 is 4. 4 times 12 is 48, and then still root 3. And so I still get the same answer, but I did do it a different way. And so you actually have that option of doing it either or. Find the area of a regular polygon. This looks like a pentagon because it has 5 sides. It tells me that my perimeter is 30. So if I take 30 and I divide it by 5 sides, because it is regular, all sides are equal, each of the length of my sides is 6 units. So to find the area of a pentagon, I'm going to go 1/2, excuse me, not that. That would be if I were to split it up into triangles, but I'm not going to do that. 1/2 A and S. So 1/2 my apothem, I don't know that yet. I know the number of sides is 5, and I know the length of my side is 6. Again, these two values here is like apothem times the perimeter, or that's my perimeter. That's just another opportunity for another way to write the formula as AP, because these two values here are perimeter. Anyway, to find the apothem, remember, it's sort of that value right in the middle here comes down perpendicular to the side, to one of the bases, which is 6. But when I cut that in half, my apothem will cut that in half equally. Then I know that's 3. Also, I have a radius here, and I need that because I need to know what this angle measurement is in here. So I'm going to use our formula 180 times n minus 2 to figure out what the sum of the interior angles is. And so that would be 5 sides. 5 minus 2 is 3. 180 times 3 is 540. So I know that the sum of the degrees is 540. But because it's 5 sides and 5 angles, each one angle, I would take 540 and divide that by 5. Each one angle is 108 degrees, 108. And so that means that when I get to this corner angle right here, that angle is just 54 degrees. So in order to fulfill my formula right here to find the area, I need to find the apothem. And the apothem is this value right here, that's straight up and down. But I only have, it's not a special right triangle. It's not 30, 60, 90. It's not 45, 45, 90. So what I need to use is trig. And I'm going to use sine, cosine, or tangent. But because I'm not trying to find the hypotenuse, which is right there, I don't use sine or cosine. So that means I'm going to use tangent. So I'm going to go tangent of 54 degrees is equal to A over 3, my apothem over 3. When I cross multiply, I get my apothem equals 3 times the value of whatever tangent of 54 degrees is. And so my apothem is equal to about, because I am in a round, I'm going to move that, make those approximates. Make sure your calculator is in degrees. So I'm going to go tangent of 54, which is about 1.37. I'm going to multiply that by 3, and I get 4.129, so 4.13. So this, my apothem value is about 4.13. So I'm going to put that up here, oh, wait, hold on. It says round your answer to the nearest tenth. All right, so I'm going to say 4.13 with the knowledge that I'm going to round this off at some point to the nearest tenth, not hundredth, like I did. So I'm going to take half of 6. 6 is 3. 3 times 5 is 15. And then that value, 4.13 0.13 times 15 is going to give me 61.95. So the area is 61.95 units squared. And so that right there is the area of my polygon. So this problem right here is a trapezoid, and it says the bases are 7 and 15. I know that the formula for the area of my trapezoid is going to be height divided by 2 times the sum of the bases. The area of the trapezoid is 66. So this is sort of working backwards because they're giving me this value, which is 66. I don't know the height, but I do know both of my bases is 7 plus 15. So I'm going to go, 7 add 15, of course, is 22. I'm going to take half of 22. So I've got my height times 22 divided by 2 equals 66. So dividing this here, I get 11. So 11 times my height is equal to 66. So h, my height, is equal to 6. And that's just 6 units. Find the height of the trapezoid. We're good. What is the sum of the measures of the exterior angles of a 19-gon? Again, you can use the formula to find the sum of the interior angles of a regular polygon. And this has to be a regular, by the way. The sum of the interior angles, which is 180 times n minus 2. I'd find one value, right, which is dividing then by n. And then that would give me an inside angle. And then in order to find the exterior angles, one exterior angle, I would take that value and subtract from 180. But that's not what they're asking. They're asking me simply the sum of the measures of an exterior angles of an 19-gon. The sum of the measures is 360 degrees for any regular polygon, for any polygon. And actually doesn't even have to be regular. The sum of the exterior angles. So what they're saying is this angle right here plus this angle here plus, and if you just keep adding all the outside angles, that's going to add up to be 360. Find the sum of the measures of the interior angles of a 13-gon. So again, I'm going to make my little facade polygon, and they want to know the sum of the interior angles, which is this angle plus all those other angles. So the sum of the interior angles of a polygon, any polygon, sum of the interior angles is equal to 180 times n minus 2. So 13 minus 2 is 11. 11 times 180 is 1980. So 1980. And that's the sum of all the angles added up all the way around. Now, again, if I wanted to know the sum of the exterior angles, again, 360. So sum of the exterior angles 360, but the sum of the interior angles is 1980. And just for clarification, if I knew that this was a regular polygon, if it was regular, meaning all sides and all angles are congruent, I could take that 1980 and divide it by 13, and each one of my angles would then actually be 152.3. which would then mean each exterior angle would be 180 minus 152.3, and that's 27.7. So I have, just different options. It depends on what they're asking me. But for right now, the sum of the interior angles is 1,980 degrees. Find the number of sides of a regular polygon if the measure of each interior angle is 150. So they're saying this is 150 degrees. They want the number of sides. So I do have a couple of options. Again, options are great. To find one interior angle of a regular polygon, the formula is 180 times n minus 2, and then divided by the number of sides. So I could do 150 degrees is equal to 180 times the number of sides, which I don't know yet, minus 2 all over n. Cross multiplying, I get 150n equals 180n, because I'm distributing now, minus 360. I would move this 180 to the other side, and I would get negative 30n is equal to negative 360 degrees. And dividing by 30 on both sides, I would end up getting the number of sides is equal to the negatives cancel. The number of sides is 12. But you would think that there would be an easier way to do this, and absolutely there is. It would be this, where you would extend this to an exterior angle. Knowing that this is 180 degrees, my exterior angle would be 30 degrees. You would then go 360 divided by 30, and that's 12. So much easier, right? But, have options is good. So that concludes the little review that we have. Now we're going to take a practice quiz. So I would prefer that you do all the problems yourself and then come back and then check your answers. So hold the video, come back and pause it, right? So our first question says that an apothem of a regular equilateral triangle is 8. So the apothem, this value straight down here that comes down, cuts that in half, is 8. What is the radius, the side length, the perimeter, and the area? So again, we're going to find the area of this triangle, and we're going to use 1/2 ANS. Apothem times number of sides times length of one side. So my apothem, I already actually have that. That's 8. And I know that the number of sides in a triangle is 3. So what I need to find is the length of one of my sides. That's all. Because I know also that this angle here, which we know that in an equilateral triangle, all the angles are 60. So what that means is that, what that means is that this angle inside here is now 30. Across from the 30 is your A value. Across from the 60, which is here, is A root 3. So that would be 8 root 3. So the length of the side, or the base, right, would be 8 root 3 plus this side, which is 8 root 3, which is 16 root 3. So the length of one side is 16, I can't see that, is 16 root 3. And then to find the area, you just simply multiply everything out, and of course leave that root 3 out. Half of 8 is 4. 4 times 3 is 12. And then 12 times 16 is what? 192. So we have 192 root 3 units squared. And that's the area of this regular polygon. For this problem, it says the radius of a square is 4. So the apothem, remember, comes up to the middle of my side of my square. The radius is 4. And across from the 90, remember, it goes x root 2. So if I take 4 and divide by 2 and multiply by root 2, one of my sides is now 2 root 2. So then the length of the one side of the actual square is 2 root 2 plus 2 root 2. 2 root 2 plus 2 root 2 is 4 root 2. So the length of one of my sides is 4 root 2. So to find the area of a square, it's just side squared. So the area of my square is side, which is 4 root 2 quantity squared, which is 4 root 2 times 4 root 2. Numbers multiply with numbers. So you've got 4 multiplying by 4, so that's 16 times root 2 times root 2, which is 2. 16 times 2 is 32. And so the area of my square is 32 units squared. And just keep an idea that in your mind that because it's a regular polygon, a square is a regular polygon. It's a parallelogram that's regular, which means it's a square. You could use this formula 1/2 ANS, which is 1/2 my apothem, which is 2 root 2, times the number of sides, which is 4, times the length of one side, which is 4 root 2. And in that case, I still get 16 times 2, which is 32. So either way, you have options, of course, to do that. For this problem, it says each side of a regular hexagon has a length of 4. Find everything. Oh, and then the last problem, I think I forgot to find the perimeter. Sorry about that. That's just going to be 4 root 2. The perimeter is going to be, the perimeter equals 4 root 2 plus 4 root 2 plus 4 root 2 plus 4 root 2, which makes 16 root 2, and that's just units. Area, oh, look at that, units squared. Thank you. For this problem here, so we know that the perimeter for this shape is just 4 times 6. So 24 units. And so my area is 1/2 my apothem times the number of sides, which we know is 6, times the length of one side, which is 4. There's my perimeter right there. And so all I have to do for this problem now is just to find my apothem. Because when I'm done, I'm going to take that and multiply by 24 and divide by 2. So remembering a hexagon from our review, we know that each of these interior angles is 120, which means that when I cut this in half with my radius, that's 60. And if this is 4, this is 2. Across from the 30 is 2. Across from the 60 would be 2 root 3. And then, so my apothem is 2 root 3. So these are going to cancel. My area of this hexagon is going to be 24 root 3 and then units squared. For this problem here, this is a regular decagon. And so this being a regular decagon, that has 10 sides. And so we're going to find the area of this regular polygon as to 1/2 my apothem times the number of sides times the length of one side. So let's put in the information we know. We know the apothem is 5. They gave it to us. We know that it's a decagon. It has 10 sides. They gave that to us. And also, because it's a regular decagon and each of the sides is 3, they also gave us that information. So realistically, all I have to do is multiply 25 times 3, which is 75, and then it's units times unit, so it's units squared. For this problem here, it says that we have an equilateral triangle and it has a radius of 4 root 3. So that means that radius is going to go to my apothem. That's going to come straight down and make a right angle there. This 60-degree angle, of course, got cut in half, which is now 30, 60, 90. My radius is 4 root 3. So opposite the 90 degrees is twice what's across from the 30, which would make this 2 root 3. And then what's opposite the 60, now this is interesting. What's opposite the 60, I need that to find my base. What's opposite the 60 is a root 3, so a root 3. So if my apothem is 2 root 3, that value goes right here. So it's going to be 2 root 3, root 3. And root 3 times root 3 is 3, because of course that's root 9, right? And square root of 9 is 3. And times 2, which makes 6. So the length of this side from here to here is 6, which would then make the length of this side also 6. And 6 plus 6 is 12. And so therefore, the length of one of my sides is 12. And this being an equilateral triangle is 12 all the way around. So in order to find my area of my triangle this way, I would go 1/2 my apothem times the number of sides times the length of one sides, which is 1/2 2 root 3 times the number of sides, which is 3, times the length of one side, which is 12. So one of these 2's is going to cancel. 12 times 3 is 36. That makes 36 root 3 units squared. And so that would be the area of this triangle using the apothem. However, you remember, you could also, option B is 1/2 base times height. So I could have said 1/2 my base, which is 12, times my height. Now remember, this is 2 root 3 and then 4 root 3 up here, because that's 2 more, 4 root 3. So that would make 4, 5, 6 root 3. And so this cancels, and I'd still get 36 root 3, and that's units squared. For this problem, it says that the perimeter is 36, and so each one of these sides is going to be a length of 6. So we're going to go 1/2 ANS. So we're going to go 1/2 my apothem, which I don't know. I know the number of sides is 6, and I know the length of one side is also 6. And so just to find the apothem, coming straight down, again, this cuts this in half. This makes that 3. Across from, this is 120 degrees, which makes that 60. That makes that 30. Across from the 60 would be 3 root 3. So my apothem is 3 root 3. I'm going to take half of one of these 6's and get 3. 3 times 3 is 9. 9 times 6 is 54. So I have 54 root 3, and then that's units squared. And that's the area of this regular pentagon. And last two questions here. We have, what is the sum of the measures of the exterior angles? One for an octagon. Here's my facade. And to be honest, it doesn't matter how many sides it has. If I'm asking for the sum of the measures of any N-GON, it's 360 degrees. If it is a regular polygon and it's a regular octagon, if I wanted to find the angle, one angle, I would take 360 and divide that by 8, it being an octagon. And that would mean that each one exterior angle would be 45 degrees, but they didn't ask that. I also could find the measure of one interior angle because I just take 180 and subtract 45 and get 135. And that would be one interior angle, but also they didn't ask that. They just asked for the sum of the exterior angles. And this question here says, find the measure of each interior angle of a regular polygon that has 10 sides. So again, there's my facade of my polygon, 10 sides. I'm going to take 360 degrees. I'm going to divide that by 10, and I'm going to get 36. And so that means that one exterior angle is 36 degrees. So if one exterior angle is 36 degrees, I would subtract that from 180. 180 minus 36 is going to give me 144 degrees as one interior angle. And just remember, of course, that you could have used the formula that said one interior angle is equal to 180 times n minus 2 all over n, and then plugged in 10. Absolutely can do that, but I think this is a little bit easier to do. So good luck on your quiz. That's your homework. Wishing you the best. Thanks so much for watching, and I hope it helped you.